Remember your basic graphs? Well, we're back to basic graphs, only now we're going to transform them. So pause your video, draw these basic graphs, and then come back to me. I'm going to draw them as quickly as possible. Parabola, absolute value, x cubed, square root of x, cube root of x. Okay, and then we have two that are, I want to consider basic graphs that we haven't talked about before. So 1 over x. 1 over x, well, if I just start plugging in values, 1 over 1 is 1, 1 over 2 is a half, 1 over 3 is a third, a fourth, a fifth, like this. 1 over 0, undefined. So let's put that in as a vertical asymptote, right? We can't use 0. So what's happening in this little gap? Well, I either zoom up or zoom down. So 1 over 1/2 is 2. Oh dear. 2. 1 over 1/4 is 4. So we are zooming up. 1 over -1, -1. 1 over -2, -1/2, -1/3. So like this. And like this. So this is the shape of what's called the reciprocal graph, right? 1 over x. The square root of 1 minus x squared comes from, just take a moment to do this. If I square both sides, and then add x to both sides, it's part of a circle. And so the square root of 1 minus x squared is the top part of the circle with radius 1. The reason I want to include that is because it's one of the few that doesn't stretch out from -infinity to infinity in either direction. Okay, so those are our basic graphs. So let's talk about basic transformations. If I took a function and added c, and let me just bring this down into view. Okay, so here's my function. If I add something to it, think about our trig graphs, right? Adding something created a vertical shift. So if I add c, my graph should move up, right? If I add a -c or subtract c, my graph should go down, right? We know that from our trig work. So f of x plus c is a vertical shift up or down c. If I add, it goes up. If I subtract, it goes down. F of x plus c. So I'm adding c to x. That is our horizontal shift. Yeah. For our trig graphs, it did the same, right? Horizontal shift. But recall, if I want to go left, I add c. And if I want to go right, I subtract c. Negative f of x. For our trig graphs, that made the highs low and the lows high. For, I don't know that I can actually get this to happen. For this, it's going to cause a reflection over the x-axis. So what was up is now down. So this is a reflection over the x-axis. So what was up is down, and what was down is up. Get rid of that. Oh, yeah, I need this. F of negative x, hopefully it will make sense then that f of negative x will take what was left and make it right, and what was right and make it left. So it's going to create a graph that reflects over the y-axis. CF of x, those were our amplitude changes for trig. For this, it's going to be what we call a vertical stretch. Vertical stretch, so the graph may get sort of distorted. It's a distortion. It's like silly putty stretching vertically. So however high it is, it's that many times higher. Or if it's negative, it's that many times more negative. Cx, so f of cx is a horizontal stretch. So however wide it was, it's stretched wider or compressed narrower. So these were like our period changes. Okay, so one of the things that you're asked to do is to take the basic graphs and write the function that shows the transformation that happened. So I'm going to do some of these. You can always pause the video and try them yourself. This is absolute value. So this is absolute value of x. It is, instead of going up, it's going down. So it's a reflection over the x-axis. It is also, the vertex has moved up 3. Okay. So it's as though someone took what normally goes this way, reflected it this way, and then shifted it up 3 units. This is our parabola, so that's x squared. But it went sideways a bit, yeah? So it's got a horizontal shift to the right 2, so x minus 2. And then a vertical shift of 3, so up 3. Okay, this is our cube root graph, and it also has a horizontal shift. It shifted left 2, so x plus 2. Now the parentheses are actually a bit redundant here. The cube root can act as the grouping symbol. So if you like the parentheses because it keeps you honest, okay, but you probably won't see them in our text or in any other text because the cube root symbol says these guys go together as long as they're under the cube root. This is our square root graph, but it is reflected over the x-axis. So this is negative square root of x. I think I probably drew it a little too steep, but let's assume that that's it. Although these two look like parabola, these are actually examples, since they don't continue, there are no arrows, they're stopping. These are examples of our square root of 1 minus x squared graph. So square root of 1 minus x squared would normally go like this. what we're seeing is that it is 1, 2, 3. It is 3 tall instead of only 1 tall. So this is 3, it's like amplitude, 3 times the square root of 1 minus x squared. This is also our square root of 1 minus x squared. So it is reflected and it is horizontally stretched. It's not vertically stretched at all, but it's horizontally stretched. How much stretched? 1, 2, 3, 4, right? What was normally at 1 is now 4 times away. And the interesting thing about a horizontal stretch is if you want it to be 4 times as wide, you use 1/4 with your function. So this is, it's also negative square root of, I'm drawing a blank here. I think, nope, I'll have to get back to you in class. I'm totally drawing a blank. Okay, I'll get back to you.